I'm working in QMO as a competence manager of software engineering and test competency. As we may have participants not from the SoftServe, I just want to say that QMO stands for Quality Management Office, what basically is like test center of in-house test center of excellence, right? Today we will talk about the blockchain technology and how does it work, and most important, how we could test it, right? Trust me, it's not that simple how you used to test application on your project. And luckily for us, Alexander Romanov, who is working on Cardano blockchain platform, will share his experience today with us. Alexander is sharing his experience through his blog as well on GitHub.io platform, and I'm finding a lot of interesting information there. So definitely recommend you to check his blog. But before we start, I would like to set up the ground rules. So we know what time we're living, right? And personal safety should be the priority for you. If you have an air alarm or you have need to leave, just leave it. Don't worry, this event would be recorded. So don't forget to mute yourself when you're joining, when you ask the question, because we may have a lot of people here, and it's much easier to speak when without the extra noises. Also, nickname are cool, but please use your real name so we could build the proper communication with you. And last but not least, so please turn on your camera as it's much pleasant to talk to faces and not to names on the black screen, right? So Alex, please tell a couple of words about you and about today's presentation that we would have.
Yep. Hello, everyone. My name is Alex. I'm working as test and deployment engineer at IOG. We are developing Cardano blockchain and other applications based on Cardano. I'm involved right now in testing applications and services that are connected to the blockchain. I've been involved in automation sphere and testing for almost 10 years right now. I worked in many products, many projects like web, mobile, and other type of applications. So today we are talking about blockchain, and I hope that after my presentation you will have like a more detailed view on what it is and how you can test it. At least how you can start to test it.
That's awesome. So we could start, right?
Yeah, we can start. So let me just share the screen. Okay. Let me share it. Okay. Can you see the screen?
Yeah, we can.
Okay, let's start. So my talk is called "What does it mean to test the blockchain?" So before we will start to talk about the blockchain and how to test it, we actually want to understand what is blockchain and what are building blocks. Then we actually will check what are the tools and approaches available to test the blockchain and how it is different to other applications. And in the end, I will share with you skills or the skill set that you need to get in order to start the test of blockchain, as well as tools and resources. All tools and resources, like almost all that I will share, I checked personally. So I hope that these resources will boost your knowledge in the blockchain, and you can start to test it as soon as possible. So the first is the building blocks of blockchain. But before we'll talk about the blockchain, a little bit of information about how we and what we have right now in web. So the web starts, as we know, in the early 90s right now. So in the web 1.0, that is from early 90s to preliminary like 2004, we had what is called web 1.0. What does it mean? So basically, we had a distributed system of these servers. On each server, we had some information, and if you wanted to get this information, you connect it to this server and get it. So basically, like at the very start, it was like only text-based information, but then it was like extended to more interesting information. But basically, in the era of Web 1.0, we mostly communicated in the internet like by reading the content, and all of the like data was stored on the server, on the file system. So if someone wanted to change this information or add some new information, they need to own this server. They need to add this information to the server, and it will be available to the user. So in this era, mostly like in the beginning of all of the things, mostly there were no authorization, no editing of information by the user. So only the server owner can edit this data. Then what we have right now mostly is Web 2.0. So right now we have a rich dynamic websites, and the biggest difference is Web 1.0 is that content right now is created by the users. So the websites actually are storing the data that mostly we created, we as users. So for example, it can be like social data, like in Facebook, or it can be video data, like in YouTube, or anything else. But it is really great for that we can create and share this content. But basically, the old data that we upload to the server basically like owns are owned by the corporation. And this data and the access to this website is actually also centralized and can be censored. So if, for example, you say something inappropriate or do something inappropriate that violates the code of conduct or like internal rules of some website or some application, they can ban you, and you will not have this access to the information. And the Web3 is actually not only connected to the blockchain, but the blockchain is actually a part of it. So the Web3, according to some people, it is like a combination between all of the latest technologies that we have right now. It is a combination of the blockchain, machine learning algorithms. It's a combination of IoT technologies. In terms of blockchain, Web3 will allow us to really own our data. So we will decide which data we want to share to which website, and if we will not want to share some data or to allow some website to store our data, we will like, actually can ban this website by ourselves. Also, using the blockchain, our data will be private and secure. But as any new like movement, any new technology, Web 3.0 is ongoing. So it's only like at the beginning. But the blockchain technologies are evolving, and other technologies also are evolving too. We will see that at some point Web3 will be on like on everyone's computer, and we will use it. So a little bit about the blockchain concepts that we need to understand before getting used to the blockchain itself. So basically, blockchain is a distributed system. It uses peer-to-peer communication. It uses public key cryptography, and it uses hashing. So that's like four basic things that you need to understand in order to actually to grasp the essence of the blockchain. So we will we will learn a little bit about this concept in the further slides. So what about distributed system? We can actually use distributed system. For example, if you type anything to search bar in Google, or if you use some big sites on the backend, actually, it can be also a distributed system. So in general, distributed system concept is when the system contains a lot of nodes, and all of these nodes are communicating with each other, and all of these nodes are tied to solve some problem. So for example, in terms of the client side, you can communicate to this system, to distributed system, and you don't know to which node you will be connected. To the user, distributed system should work as a regular system. So if you want to write some data or do something, you can do. But for example, client one, when it makes call to the system, it can be connected to node 1, and client 2 can be connected to node 3. But for both clients, everything should be the same. The next is hashing. So it is interesting concept, and it is used not only in the blockchain. It uses so you can find it, for example, if you are working in test automation. So the most widespread thing where you can find it is it's in the data structures, for example, like a hash set or a hash map. So basically, hashing allows, it's like mathematical function that can transform data of any size to data of the specified size. And another things that this hash function is interesting, that if you change anything in the input text, for example, as right now we have the hash function like input that is called test engineering node, it produced like hash function to produce this hash, like 1, 6, and other things. But if you just add one thing or remove one thing, one letter, the hash will be totally different. For example, even if you provide an input of one letter or one symbol, the hash will be like the output data will be the same size. So the most like widespread using of hashing and hash function is when we want to check if the data was modified. So for example, if you are sending a message, a letter, and you want to check if someone captured this message and modified it, so you can with this letter you can send the hash of this letter, and then if someone changed the input letter, you can compare the hashes. If their hashes are not like equal, then something was wrong and you were hacked. The cryptography is actually a vast topic. It's completely like a big science thing, but basically in the blockchain, it is used really like in a limited way, like on the basic side. So it uses for encryption and data like digital signatures. So for symmetric encryption, basically encryption is when you want to hide information from a third party and you want to share this information between you and some other user. So you just you can encrypt this message using some key. Then you send this cipher text, so the encrypted text, to the user, and the end user will decrypt using the key and get the message. The essence of symmetric encryption is basically that we use the same key for encrypting and for decrypting. Comparing to the symmetric encryption, asymmetric encryption, the one biggest difference is that we use different keys for encrypting and decrypting. It is like a big advantage because in the previous scheme, when we have one key, in order to actually communicate with, and in order to perform encryption and decryption, you need to securely transfer this key to the end user, to your receiver. But as for the asymmetric encryption, you can share only the public key, and private key will only be available to you. And the last thing is communication. So we all, as we are working with mobile technologies and web technologies, we all actually get used to the client-server model. So we have a server and a lot of clients. It can be web browsers or mobile applications that performs the requests. Server will gets its requests and then sends it back all of the information that you requested. So we actually more or less know how to test it. But despite of this model, there are other models. For example, like peer-to-peer model. You can recall, and you actually can actually use this model if you use some technologies like, for example, torrent. So if you ever use torrent under the hood, it is like a peer-to-peer distributed system of nodes. So basically, peer-to-peer means that instead of having one big centralized server and all of the clients, we don't have a server, and all of the information actually spread between the clients. So the clients, or every nodes in the system, are peers. So if you want to get some information, you just connect to other peer and you check whether that information is on this node. If not, you just need to make a request to another peer. So peer-to-peer model, of course, it has advantages and it has disadvantages. The main advantage is if someone can stop your website or your system from functioning. For example, some malicious user can perform distributed denial of service attack to the server. So this malicious user will just get your server out of the internet or blocked it, and then all of the system will be unavailable at all to the user. And as for peer-to-peer, it is impossible, because if you ban or if you block one peer, the other peer can always use other participants of the network. So we just checked all of the 4 components. Then what is a blockchain? Basically, the blockchain, as it was described in 2008 in the famous white paper by Satoshi Nakamoto, it is like a distributed database or distributed ledger that is spread to peer-to-peer network. The interesting thing actually is how the data on each node. So on each node, on node 1, 2, 3, 4, it will be the same copy of this database of distributed ledger. And the interesting thing is how the data inside of this ledger is structured. So basically, all the information is stored as transactions. So for example, when you send some money, if you're talking about currency things, so transaction means you send some money to some other user. So it is a transaction, or the user sends money to you. It is another transaction. All of these transactions are up to some amount, are stored, and then it is aggregated into the block. And when the block is prepared on one of the nodes, then this block is spread to all of the nodes. And the interesting thing, and actually why the blockchain is called the blockchain, is actually each block, when it is created, except of the first block in the blockchain, it has a hash of the previous block. So and as you can see, in block 1 we have a hash of block 0. In the block 2 we have a hash of block 1. And actually we have a chain of these blocks. And why do we need the hash of the previous block? And it is the biggest like advantage of the blockchain that we have right now is when someone wants to modify, for example, at the point of creating of block 2, some other malicious counterparty wants to change some transactions or all transaction or even for example substitute the whole block, then it is not like it is almost impossible to do it because you need to change the block itself. You need to then change all the blocks that are after this block, and you need to spread it to the network. And also you need to actually to wait until all of the nodes will accept all these blocks. So basically, it like technically speaking, it is possible to do, but it actually you need a lot of resources, like hardware resources, and you need a lot of money in order to recreate your blockchain. And the biggest and also an interesting thing in the blockchain that all these transactions that are actually stored in the block, they are accessible, so everybody can view it. But the transactions actually stored in that way, so you can view from who to which address you spend you transfer this money. But this like the input and the output is not possible to get this information. So basically you can't reveal for example the receiver of this particular money, of this pile of money. So if ever if anyone on the internet says that blockchain is totally secured and you can't get information about who transfer money to whom, it is partially true, because you can reveal the amount, but you can't reveal the addresses of the receiver and the sender as well. So in this particular case, we actually have like a preliminary understanding or like a picture of what is the blockchain. But then let's go and see how we can test it and the essence of this talk. So if someone talked about the testing of the blockchain, it can be understood in a totally different ways. So first of all, you can join some company or some project, and you can test the blockchain internals. So you can test the code of the blockchain itself. So it means you will test, for example, like how the nodes in the blockchain are communicating, how the encryption protocols inside of these nodes are working, as well as how the consensus protocols or algorithms are used and whether they are working properly. The data replication, the performance of the blockchain and the security of the blockchain, like as a system, its fault tolerance, or different incentive models for these for nodes that performs the validation of the transactions. But also, when we speak about testing of the blockchain, you can test the wallets. Wallets is a special program that actually allows you to transfer money from you to someone else, or to receive money. Wallets can be a software, basically like a website where you can join, like register and perform these actions. Or it can be even hardware wallets. So it is like a device, hardware device that you can use in order to actually generate these keys for performing these like sending or receiving operations. Also, when we test the blockchain, we can test a lot of like cryptocurrency exchanges we right now have. So it is like a website where you can go and you can change one cryptocurrency to another, or one real currency. So you can buy for your hryvnia or dollar or euro, you can buy or sell your cryptocurrency. So the interesting thing here is that there are like tens of thousands different cryptocurrencies on the market, as well as like regular currencies. So you should be prepared to test a lot of like third-party integrations, a lot of like data management from various sources, and you need to test also security. So how well and how secure is the account of the user? So is it possible to easily break into account and steal the tokens or steal these crypto money, let's say. And the last thing is when we are talking about testing a blockchain, you can test blockchain-based applications. So basically, it is an application that use a blockchain in some way. So how it looks like actually, the architecture of the typical application, and actually in the blockchain world, these apps are called decentralized apps because they are using the blockchain as a decentralized system. So the architecture of the system are pretty like, from one point of view it is simple, but from another it is like complex also. So we can have like various users, like web or mobile users, that communicates with your system. It is your system that you are testing. You have a lot of things that is going on the application level, but also in some way you can communicate to the blockchain using the blockchain API. So the blockchain itself, it's a third party, it's a system. The only thing that you are communicating, you're using, it's actually an API. It can be HTTP REST API, it can be GraphQL API, it can be gRPC API. So it depends on the particular blockchain, but basically you need to understand what you are submitting to the blockchain, how it is processed, and what the blockchain will get in response. Also, as well, you can communicate with some storage, some database. So you can use in your application any centralized storage that we actually get used to. So it is SQL or NoSQL databases, whatever you use. But as well, it is possible to use some storage that is decentralized. So for example, you can use IPFS, it's interplanetary file system. Basically, it is file system to store files on the blockchain. So it has also the drawbacks and the like pros and cons. But if you want to store information, you can use an API of this IPFS and store it. So you need to understand what you are storing on this decentralized storage, and whether actually everybody will access this data or not. Next thing is like, what are the blockchain-based applications? So basically, one thing that you may test, it's the usage of smart contracts. It's a piece of code that you can create, or developers can create, send to the blockchain, and they will do something. They will do some code or some logic on the blockchain. The advantages is that you can create this smart contract, send it to the blockchain, and actually just get it like it will work forever until you will stop it. For now, even the Bitcoin has its own smart contract language, but as I will show you on the next slide, it's a little bit like low level. The most widespread thing in the smart contract world right now is that you can access easily. It's the smart contracts that are written in Solidity and are executing on Ethereum blockchain. On the Cardano, we have two smart contracts languages. One is the Plutus, and the second is Marlowe. So the Plutus is more technical things, but Marlowe is actually like language that you can compose from the blocks your contracts. Also, the blockchain-based applications, you can use and manage your identity. So basically, you can create your IDs and send it to some other applications, or even to your universities. For example, in some universities, they are using the blockchain to store the information about diplomas of their students on the blockchain. So everybody can check whether your diploma are valid or not, and this information are instantly available from the blockchain. The biggest thing right now on the blockchain that is blockchain-based application is anything connected to the decentralized finance. So basically, it's financial applications that are on the backend, somewhere deep on the backend, that are using smart contracts and the blockchain itself. So basically, in order to test these applications, you need to understand the finance and how it works. The next thing is, right now, it's only like the beginning, but for almost for all the applications that we use on a daily basis, we have right now I don't know about the competitor, but at least like an alternative from the blockchain world. So we have alternatives to YouTube, to Instagram, to Twitter, even to LinkedIn. For example, like the Twitter, as I know, the previous CEO of Twitter is actually creating a new a substitute of Twitter that will be run on the blockchain, so it can be cancelled as all. So it will be like secure and more or less free. Also, on the blockchain, there are interesting things like ICOs or centralized autonomous organizations. But basically, you will participate if you join to blockchain startups. You may participate in ICO. So basically, it means initial coin offering. It's similar to IPO. So basically, you create your startup can create a bunch of tokens, new tokens, new currency, and some users can buy this currency and use it, or they can wait until this currency will get more traction and more price, and then sell it. So it is an interesting examples of how the smart contracts may look like on different platforms. So basically, here we have a Bitcoin script. So it is a thing that you can include in the transaction, and it will perform some amount of operations. But basically, I can compare it. If you are working with programming language, I can compare it a little bit to the assembler language. So it is low level, and it is very, very limited. So basically, in this scripting language, you don't have loops, you don't have a lot of useful functionality. So it is very limited. For example, in Solidity, it looks like a little bit like a JavaScript. So it is Turing complete language, basically. So you can perform anything using this language, and all of this code will be executed on Ethereum. And the Plutus, it is a language that is available, one of the languages that is available to the Cardano platform. So basically, it's a subset of the Haskell language. So the biggest advantage of this language comparing to Solidity is, yeah, it is a little bit more complex, but it contains a lot of things, like a lot of checks and verifications in the language itself. So it is not possible to get many problems or issues or security vulnerabilities that it is really easy possible to get on Solidity, but on Plutus it is almost impossible. So the next thing, the biggest and interesting thing is challenges. Why it is challenging to test the blockchains and blockchain applications. So first is in order to understand, you need to actually have to more technical knowledge. You need to understand how the different blockchains are working, what are the differences, how to use it, how these models and consensus protocols works. Also, you need to understand a little bit about distributed systems. So in order to perform testing well, of course, you can use for example, cryptocurrency exchange without the knowledge of the particular blockchains, but it will be just very high level test. Maybe it will catch some bugs, but in most cases For the more complex bugs, you will not be able to do it without any knowledge. Next thing, and the biggest and interesting thing in the blockchain. So when I explained the blockchain concept, I said that the blockchain is a distributed database. It is true, but the interesting thing that comparing to the databases that we get used to, for example, like SQL databases. So when we are testing or using it, so we are preparing test data, we are storing it on the database, then perform a test, and then delete this database, delete this data from database. It is our typical workflow. But in the blockchain, you can't actually do it because the blockchain, like each data that you save or you store on the blockchain, it is unchangeable. So if you send something to the blockchain, it is validated and added to the chain, you can't delete it. It is not possible to delete it. The only way how you can delete it, you should recreate the blockchain like from scratch. But for real world blockchains, it is not possible. So because it is used by many users and it contains a lot of history. So if you are testing the blockchain itself, or you are sending some data to the blockchain, you need to be very, very careful with the data, for example, if you are sending some test scenarios or test data to the blockchain, you need to understand that if you save something sensitive, for example, to your organization or even to your users, it will be stored and you can delete it. So it is an interesting concept. The other concept is more related to the Ethereum blockchain. Is actually so when you create a smart contract and you want to run it, like perform a code execution on the blockchain, you need actually to pay for executions for each operation. So of course, when you create a contract, there are tools on the market that can predict, or they can check the preliminary price of your execution. But for example, if you or your developer made a mistake, or it's like the smart contract contains, for example, like a really like unintentional loop that is like runs forever, then you can actually you can spend a lot of money. If you are working on the test version of the blockchain, it is okay because you can just get another test money. But if you are working on the main net of the blockchain, it can cost you a lot of money. Of course, you can have like a high you can have this point up to which you will stop the execution at some point, but before that you can spend a lot of money even on testing on the let's say production version of the blockchain. So you need to take care and you need to test it before you releasing something. Also, it is an interesting thing in all the blockchains that is right now, all of the blockchains have like some issues with or not issues, it's limitations of the how many transactions they can validate or process per second. So comparing to the like payment providers that we are using right now, like the biggest payment providers, for example, they can process up to like 100,000 transactions per second. So some like the most widespread blockchains can operate like only like hundreds transactions per second or thousands. So, but of course, it is due to the technical or to the architecture of the system and how they are done. The next thing is actually you need to be aware that in the blockchain there are a lot of unusual languages and custom protocols. So you need, for example, some blockchains are using gRPC, so you need to understand what it is and how to test it. And for now, it is not possible to find a universal tool. Like for example, for web, you can use at some point you can use Selenium WebDriver and you can automate everything. But as I mentioned, we have like 10,000 currencies. But as for the blockchains, it's like hundreds of different blockchains right now. Some of them are forks of the Bitcoin, so this looks like a Bitcoin, but some are completely different. So you need to, if you are working with this project, you need to understand their tool set and how they are working. So for now, there is no universal tools. So the last thing is actually skills, tools, and resources that you need to understand and you need to get before, or if you want to start to test the blockchain. First, what you need to understand. As I mentioned, you need to understand hashing, cryptography, consensus protocols. The most widespread is proof of work and proof of stake. A little bit of distributed systems, like networking, also how how networking works. As for API testing, some of the blockchains, of course, are using HTTP API, but some are using gRPC, GraphQL, or WebSockets. If you're working with specific projects, you need to understand the specific project. As for programming, I can't say that you need to learn all of these languages. It is not possible at all, but at least you need to learn at least one of them. So for example, for smart contracts on Ethereum, you need to learn Solidity, or for example, like if you know one programming language, basically you can learn another one. You may need to learn and to understand what Docker is. And if you're working with decentralized finance, basically you need to understand this how the finance works and how it works specifically on the blockchain. Tools. That are tools that I'm using on a daily basis. Our projects are based on Scala because that's why the most of my tools are connected to Scala. But for manual gRPC testing, I'm using Krea app, but there are also another tools available on the market. For example, as I know, even Postman right now have this possibility to send and receive the gRPC requests. So if you know Postman well, so you can learn it very quickly. But for a different project, what I can recommend you to check out is actually the Bitcoin is open source project, so you can check the tests actually. The tests are available on the GitHub. And you can, for example, check the Bitcoin J library for Java to test the blockchain if you want. For Ethereum, there are plenty of tools, like Solidity coverage is for coverage of the code. Waffle and Truffle, it's even a platform for automation of the smart contracts. And there are other tools available, for example, for dynamic and static code analysis. It is like, in most cases, it is like a really deep testing. So for basic automation, it will be enough, like, for example, to use Truffle. For Cardano, also for the actually Cardano network, it is Cardano tests available. And there are some libraries for Plutus. For example, you can use property-based tests for Plutus. It is also a handy thing to check various inputs for your smart contracts without deploying it to the real chain. And the last thing is resources. Actually, it is like a very, very handy thing in my perspective. So I started with a blockchain a little bit like maybe a year and a half ago. So when I started, it was from one perspective, it was a lot of information about the blockchain, but from another, it is like a very much of this information were just copy and pasting from one resource to another. So after it's like at some point you understand that you need to learn more or you need to learn deep. So what I can recommend, it's all of the resources that I checked personally. So for example, from the books, the biggest and the best thing that is available is blockchain and decentralized systems. It's actually a three like medium-sized books, part 1, part 2, and part 3. Actually, it provides you all the knowledge, like technical knowledge, because it's like a book for universities, all the knowledge that you need to understand blockchain and decentralized systems. For particularly if you want to understand the blockchain, how it works, it is also a good book. It's called Mastering Blockchain or Mastering Ethereum for Ethereum as well. Courses, both are like specializations on the Coursera. One, it is for blockchain itself. The second is decentralized finance. So you can use it as well. And if you want to get a lot of like aggregation of posts on the blockchain testing team, I created the awesome blockchain testing list, so you can check it as well. And right now I'm like producing a set of series of blog posts that are called blockchain for test engineers, where I try to explain blockchain concept and things from the viewpoint of the tester. So what we have in the end, yes, blockchain is not only the Bitcoin, it's just a technology that has its pros and cons. You can use it or you can ignore it, but basically at one point it will be like pretty widespread in the world. So you may need to understand it, maybe if you will use it, or if you will join the project that is using the blockchain, you need to understand it well. Of course, blockchain brings a lot of new challenges, so you don't have a lot of tools for it, like comparing to the web, of course, or even the mobile. And you need to learn a lot of internals in order to test it. And blockchain right now is actually constantly like evolving. So the evolution is not like it's not stopping at some point. So there are a lot of new blockchains on the market. There are new like technologies or new approaches that are just appearing, but some of them even appearing in the way of or in the form of the white papers from these like from the academic papers from some professors from the universities, but maybe in half a year or a year it is a real working solution. So it is really interesting to see how from the theory you can get to practice with a minimal amount of time. So that's it. You can write me in Twitter. You can check my blog. If you are using Ukrainian language, you can check the Telegram channel as well. And just if you want to talk about the blockchain or anything related to automation technologies, you can write me, and I'm always eager to chat about it or to help you with something. And that's it. If you have some questions, that's the time to ask the questions. And thank you for your attention.
Thank you very much, Sasha, for such awesome presentation. Yeah, before you typing the question, guys, I would like to remind you that we would have the next session, which called like testing games. It's not playing games, right? It's about the way how we would test not the blockchain but the games, right? So we invite you everyone for joining the session for today in the evening. Yeah, and we have a question. The question is like where and how do you store test cases, or whatever you use, how long one test check could test?
Okay, so personally on my project right now, all of the tests, I try to automate the as much test as I can. So basically, it is like in the form of a checklist or a test report. It is generated automatically after the automation tests are executed. And some of the tests are actually stored in the form of checklists, just the checklists. But if you are talking about like the specifics of the blockchain, of course, for example, if you are testing or performing a test that is making a transaction to the chain, it is not instant, that as we like can expect in the, for example, banking applications. So you are storing something to the database and you just in a few seconds you get the results. When you submit your transaction to the chain, it is added to the block. The block is spread to the chain, and then a few nodes in the chain should validate this block and to like accept this block. It takes time. For example, let me just make an example. In the Bitcoin network, it takes like at average, it takes like 10 minutes to get a new block. So in order to check, for example, if your transaction is completely valid, it is added to the block and it is accepted to the chain, you need to wait 10 minutes. In some other blockchains, it can take, of course, less, but it also takes like half a minute or a minute, so it takes time. You need to know about it. It's how the way it works.
Okay, thank you. Also, if someone has a question, you can ask by voice. Just unmute yourself and ask.
Hi, my name is Nicola. You said that Ethereum network is actually paid, so you have to pay for any transaction you made in the network. What about other networks like Cardano? Is it completely free?
It is not completely free, so you need to also pay. But for example, the price for making a transaction, it is a price, but it is right now like only fractions of one ADA. It is native currency for Cardano. So basically, for testing purposes, you can use the testnet versions of all of the systems. Bitcoin has testnet version, Ethereum, Cardano as well, and other blockchains as well. So here you don't need to pay real money just to test it. But for production tests, you need to pay real money. And you need to, for example, you need to structure your tests in that way that it will check what it needs to check, but actually it will spend as little money as possible. But of course, you need to check on the production.
One more question from automation perspective. For example, you need to have like several auto tests which runs on real test blockchain, and you know that blockchain charge you for any transactions. Do you prepare some accounts and charge them, like top up and use for auto tests?
Yeah.
Because as far as I know, you cannot get your money on the way, so you need to prepare them prior to running tests.
Yeah. So if you're talking about using the real money and real accounts, yes, you need to create these test accounts, maybe not one, but multiple test accounts. You need to actually top up these accounts with the currency, native currency for the blockchain. And then inside of the test, you will spend this currency inside of your tests. And actually, you need also to be aware on how blockchain works, because there are two types of working or two types of transaction management, let's say, on the blockchains. For example, Ethereum is account-based. It's, for example, if you are spending some transaction or some money for sending it to another account, it is just like adding to the global state of the network. So it is like how we get used to it. But for example, in the Bitcoin and in the Cardano, it is unspent transaction output model, UTXO model, and it is a little bit complex. And even if you have enough currency on your account, you may be at some point a little bit blocked from making new transactions until the previous transactions will be confirmed by the chain. So it takes a little bit lag to testing and to processing, but it is done in order to actually to make sure that this transaction will be secured.
Thank you.
And I have a question regarding the hardware. Do you use because like you mentioned that the blockchain is like is big, right? The database is big, the encryption, and you need to know is like a CPU intensive task and so on. So do you use a regular laptop, or you have some like workstation or a server?
Actually, like I don't have like a really big laptop, or let's say powerful laptop. It is a little bit regular. but I don't need, hope, like for now at least, I don't need to just have like 2 or more versions of the mainnet on my laptop. Of course, if you need a powerful machine, you can always use the cloud providers for it. So it is a really nice solution. So you can use it with any laptop. But I know that like some developers, yeah, they need that's actually working and that are creating a code for the blockchain itself. They need to have a really powerful like laptops or computers.
Yeah, looks like we have, no, it's not the question. Yeah, so we answer all the questions. So thank you very much, Sota, for the great presentation.
Thank you.
And also,
Actually, yeah, the draw.
if you don't mind, I just wonder about the mining. Is there any testing activity regarding mining data centers? Can you just cover this part, please?
And what are actually the questions? So the process of mining, of course, it is tested. So because the mining actually itself, it's the algorithm. It's a mathematical algorithm, and it is tested. It is tested, and you don't need to, for example, in order to create this algorithm, you can actually make it tweaks to it just to make it like more testable on your local machine. But of course, in the real system or the mainnet, you need also to test it, but you are testing it with real devices. And I know that even some developers, they have also their actually a lot of like not a mining pool, but the powerful computer for checking the mining algorithms. But for example, the mining process actually it depends on the incentive model or on the consensus protocol of the blockchain. For example, in Bitcoin right now, it is proof of work. So you need to mine, you need to spend a lot of resources to mine something. In the Ethereum, it was previously until the September right now, it was proof of work also protocol, and you need to spend a lot of resources. But right now, the Ethereum switched, as I know,
Proof of stake.
Yeah, to proof of stake. I don't know for everything, but they tend to switch. And for example, in Cardano, the proof of stake is built in the protocol, so you don't need to spend a lot of resources. You don't need to create like a mining pools to just to produce new blocks. So it is totally different model and totally different ways how to check it.
Yeah, I see. Thank you for the explanation.
Yeah, thanks.
Yeah, so we're running out of time. So thanks everyone. Thank you, Alexander, one more time. And stay safe and have a good day.
Yeah, thanks.